Alright, I really like this problem, and I'm going to move quickly here because I'm going to show you two different ways to evaluate this integral. Alright, first of all, do you see that the integrand is x plus 6? Hey, that's just a linear function. Alright, it simply looks like this. On a graph, I've got one right here, on a graph I have a slope of 1 and a y-intercept of 6. Alright, so here's my y-intercept and a slope of 1. That is, go up 1 to the right 1, or rise 1, or rise of 1, run of 1. Or you can go up 2 to the right 2. Alright, now notice that these intervals are in, the plots here are in quantities of 2 instead of 1. Okay, so I've got a y-intercept of 6. I'm going to go up 2 to the right 2. It puts me there, up 2 to the right 2, etc., etc., or 1 over 1, however you want to see it. But this is what it looks like. It's just a simple line, right, connecting these dots, and it looks like this. Okay. Alright, now that I've got that, what we're going to do is we're going to evaluate, alright, we're going to evaluate this this function and integrate it between -4, here it is, I'm going to slide this up, between -4 and 6. Hey, that's between here, -4 and 6. Okay, so we want to know what is this area. We want to know what is the area, right, of all of this shading going on here, okay, between -4 and 6. Well, if you turn the paper this way, you turn the graph this way, do you see that what I actually have is a trapezoid? Right? All of this shaded area is simply a geometric shape called a trapezoid. Right? And the way that trapezoids work is you can find the area of a trapezoid, I'll write this right here, area of a trapezoid, by taking 1/2, right, the sum of the two bases. Now I'm going to put big B and little b for big base and little base, all right, times the height of this trapezoid. Now if you turn it this way, do you see that the big base of this trapezoid is this distance here, right, this distance here, which goes from 0 to 12. So that base is a base of 12, a length going all the way across. That's big B, okay? And this little b right here is a distance of 2. Alright, so I just went up 2 spaces. So my little b was 2, my big B is 12. And this area right here, this length right here, is my height. Alright, so I'm going from -4 to 0, well, that's distance of 4, all the way out to 6. So 4 plus 6, hey, that's a total distance of 12. Alright, I've got everything I need. This is my little b, this is my big B, capital B right here, and I've got a height, right, that was my big B, and I've got a height of 10. So using my trapezoid area formula, what I have is I've got 1/2 the big base, which was 12, plus the little base, which was 2, times my height, which is 10. And I hope you see that that's just a 14 inside the parentheses. Half of 14 is 7, and 7 times 10 gives me a total area of 70. Okay, so that's one way to evaluate this, knowing that my integrand x plus 6 was simply just a line. That's all it was, right? And we were out evaluating between -4 and 6. So my total area, in this case happens to be a trapezoid, was 70. Alright, but what if you didn't want to graph it? You could actually work this problem out using another method. Here, let me show you the other method, and that is with the Fundamental Theorem of Calculus. Okay, the Fundamental Theorem of Calculus says, all right, first give me the antiderivative, all right, of all the terms of this integrand right here, which I hope you see is simply x squared over 2, right, for that first one, and this one here is 6x. But what we're going to do is we're going to evaluate this between -4 and 6. And so the Fundamental Theorem of Calculus says, okay, you're going to have two quantities and you're going to take the difference of them. All right. The first quantity is take your antiderivative and plug in a 6, the upper limit here, this upper integral. You're going to plug in a 6 everywhere you see an x. Okay, so that's just 6 squared all over 2 plus 6 times 6. Right. And from that, we're going to subtract the exact same thing. Okay, so again, I just plugged everywhere I see an x, I plugged in a 6. Okay, I'm going to do the exact same thing everywhere I see an x, but this time I'm going to plug in the lower limit here, which is a -4. All right, so I've got -4 squared over 2 plus 6 times -4. Right, and again, I plugged in a -4 everywhere I saw an x. Alright, so here's a little bit of math. This isn't too hard. Alright, I've got 6 squared, which is 36, half of 36, which is just 18. Alright, so this first term here turns into an 18. 6 times 6 is 36, so we're going to add these up in a second. But do you notice that there's a coefficient of 1 out front that doesn't change in either of these terms, so I'm not going to bother putting the square brackets around this anymore. Okay, here comes my minus sign, and look, this first term is positive because I have a negative 4 inside the parentheses. That's negative 4 times negative 4, which is positive 16, and 16 divided by 2 is 8. Right? Okay, and over here I've got 6 times negative 4, which is a negative 24. Now I'm keeping this one in brackets. Why? Because there's a negative sign in front of it. Okay, so if you want to work this out, I guess you can do it this way. You can do 8 minus a 24, which is just a negative 16. But this negative 16 has a negative sign in front of it, so this negative changes that 16 to a positive. All right. So my final answer is this. Let's see if I can squeeze it on the bottom here. My final answer is, look, I've got 18 plus 36 plus this 16 over here, giving me a total of, hey, isn't that a total of 70? That's exactly what we had from before, right? Exactly what we had from that previous answer of 70. So this is solving this integral using the fundamental theorem of calculus. This first method I showed you was solving it using actual area formula. Hope that helps.